Hey students, physics kids, how are y'all doing today? It's Mr. Goya coming at you. I wanted to make a video of this first activity that we're going to do, lab number 1, lighting up an LED. And what I've done is I've created kind of a handout for you, and I'll make sure you get the link for that. It's a pretty easy activity, but I kind of wanted to do it with you on the computer here. And the schematic's pretty easy. We really don't even need a breadboard. I'm going to be kind of following along this schematic and when I create this video. So the first thing we really need to do is to open up a new, let's see, let me open up a new Google Doc, and let me slide it on over here. Oops, can I get it all in there? Let me maybe make it a little smaller here, so we can get it all on here. There we go. And actually, let me maybe make it a little bit bigger too. I think that's good. And let me go into the tinkercad com site here. Let me let that open up here, and let me go ahead and log out. And so this is probably what you're going to see, and I'm going to sign in as a student here. So I'm going to type the class code 33LF TAQL 1CN1. I'm going to go to the class, type in my nickname as a student. That's my first name, my last name, student, and then 4808. That's me. Okay, let's let it open up. I want to click circuits. I want to create a new circuit. I'm going to put in a new name here. I'm just going to call it Lab1 LED to light. I mean, the name of my circuit here. And we don't really need a breadboard for this, so we only need a few things. But let's first put in the batteries, so you can search for the different components over here. And let me kind of put it over here. And we want 2 batteries to give us, then in series, to give us 3 volts. And when I have the batteries kind of clicked, I can hit the R button and I can rotate things around, move things kind of around here. And what we need then is a resistor. Oops, there's my resistor. I'm going to put it in, just put it right here, and we want this to be a 470 ohms, so we can change it here. 470 ohms. That's going to change the colors, and I think I'll rotate it around too. And then we want our LED. So I'm going to put it on the screen. Now, a resistor has, again, 2 terminals, but this is what's called a nonpolar device. An LED, on the other hand, has a specific, again, it's got 2 terminals. It's got a cathode, that's a negative terminal, and the anode, that's the positive terminal. And let me go ahead and maybe rotate that around a little bit here too. Now, what I want to do here is set up some meters. So let's go ahead and put in, before I do that, on this LED you can have some choices of colors. And if I click on it, you can do green, yellow, orange, blue, red, white. I think I'll just hang on with red. Not a big deal. Well, let me put in some meters. Let's put in a multimeter. Let's actually put in several. So again, the multimeter, we can set it up to measure voltage, current, or resistance. Voltage, amperage, or resistance. Now, if I want to use the multimeter to measure resistance, I can basically put one lead to one side of the resistor and one to the other. When I start the simulation, then it's going to record that resistor is 470 ohms. Now, we can't really use this multimeter while we have the circuit going as an ohm meter or to measure resistance. We need the circuit to be off to measure the resistance. And anyway, I kind of know what the resistance is anyway, so no big deal. So let me take these wires, let me stop the simulation and take these wires and off. I'm going to move it maybe over here. I'm going to use this one as an ammeter. So I'm going to change this to amperage. And then let me also put in one multimeter to measure the voltage drop here. And then I'll put in an ammeter to measure the voltage drop there. And then I'll measure the complete voltage drop across both devices. So I've got one meter here that'll be for current, and I'll have these to measure voltages. Now I'm going to kind of turn this over here, maybe get it a little bit closer. I'm going to turn this over, I'm going to turn this one over here, and I'll kind of rotate this one too. And I think I will rotate this back now. Maybe slide it over here. So let's just make our complete circuit here. So we've got our positive lead, and I want to create a wire to the positive lead of my ammeter. And then I want to put a lead from the negative part of my ammeter into the resistor. Then I want to go from my resistor and I want to go to the anode of the LED. Let me make sure I'm on the anode. And then I'm going to go from the cathode, my negative lead from my LED. I'm going to have a wire to my negative terminal of my batteries. Alright, so now when I start the simulation, I don't have any measurements on my voltmeters yet. I'll put those in shortly, but I'm getting a current then in the circuit, and I see my LED kind of light up there. Alright, so let me go ahead and stop the sim. So we'll take a wire from this voltmeter, and I'm going to put it here because that's the positive, really, that's where the conventional current's coming into my resistor. Oops. There we go. And then I'll take another wire here. Then I'll do the same thing here. This is my positive. It'll go to my anode. Oh, I got it on the wrong one. There's my anode, and then to my cathode. And then I want one around both devices. So I'm going to have a wire from my positive to this part of my resistor, and then to the cathode. of my LED. You know, one great thing about simulations really is you can have lots of different meters in. You know, if we were really building the circuit with all of this, we'd have to have, you know, 4 different meters, etc. Now let's go ahead and start the sim. So again, the battery's creating a push, a voltage. It's pushing the conventional current, we would call that positive charge, around in the circuit. We have then a voltage drop here and a voltage drop here. So the LED has a voltage drop of 1.87 volts, 1.12 volts here, and I get again a total voltage drop of 3 volts. So the battery is supplying 3 volts. The device is, in this case, the resistor, and the LED then are using that push. Now we can kind of see a brightness here. Let me actually turn off the lights here. I don't know if that'll help or not, so I can see my computer screen a little more. I don't know if you can kind of see that pretty well, that brightness here. We could maybe change it. Oops. Well, we could change the color of that LED. I'm not sure it really matters. So for example, if I've got this resistor at 470, if I make this resistor, let me stop the simulation. Okay, look at my values here. If we stop the simulation, and if I make this resistor a little bit smaller, let's say maybe 100 ohms, okay, what are my meters going to do? Okay, should my current be greater? What about my voltages? Well, I've got it now at 100 ohms, so let me go ahead and start the simulation. Okay, so I had 470. I kind of forget what my values were. Oh, 2.39 milliamps, and I'm down now to 100. Okay, my current now is greater. I've changed my voltages here, so I have less of a voltage drop here, more here. My LED appears to have gotten brighter. Does that make sense? It should. And again, my total voltage is going to be about 3. I've got 2.99. Now if I stop the simulation, and I was at 470, maybe let me put it up to 1 kilo ohm or 1,000 ohms, start the simulation. My current now has dropped, and my LED now is less bright. You know, if we were to maybe put on 10,000, I can now barely see, that'd be 10K. You know, now I'm in microamps, but I can barely see that LED. You know, if we take it back, if we take it even smaller maybe and do maybe 10 ohms, let me hit start. Okay, now I've got 58.4 milliamps. You know, I've got more voltage. Most of the voltage now is, you know, being taken up by the LED, but I've got this little problem here. It says the current through the LED is 58.4, while recommended maximum is 20 milliamps. Okay, so that's kind of a problem. I've got too much current flowing through this device now. Now, if we were to stop it, and even, you know, if I basically take my resistance down to 0, okay, that'd be just like a wire, right? And start the simulation. Whoa, boy, look at that. You know, I probably fried the LED, didn't I? Okay, well, that's, I think, kind of what I wanted to show you. Now, here's kind of how I want you to document this into the checkpoint. So let me go ahead and stop the sim, and I'm going to go over and click this icon, the tinkercad icon. So here's the circuit I just created. There's my name. So what I can do is do a little snip here. So I can go in and click a new snip, and that's got my name on it, and it's got the circuit that I just built, that I just put together here. Make sure you're on circuits here too, right here. And this then can be copied, saved or copied or put into that checkpoint document. Does that kind of make sense? That's kind of what I'm looking for here. Hey, hopefully you had a pretty good circuit there. We'll talk to you later, physics kids. Bye.